Welcome to the Sages Climate Science Podcast. I'm your host, Laura Young, environmental scientist and science communicator. And today we are going to the coldest parts of our planet, something called the Cryosphere, which we will hear a bit more about. But I'm delighted that we've got some amazing guests. Emma Cameron, welcome to the podcast. You are a PhD student at the University of St Andrews, and you are looking at the relationship between the Greenland ice sheet and the ocean. And this is the fastest growing contributor to global sea level rise. And this is, really vulnerable when it comes to the oceans. And you have been a part earlier this year in going to the Thwaites Glacier. Is that right?
That is absolutely right.
Amazing. Yeah. And this is in West Antarctica, and you were there with the British Antarctic Survey and the US Antarctic Survey, and you were there with TJ, who's also one of our guests, and you were looking as part of a 16-person team at the global imaging of the lateral margins of this to understand how it might evolve and respond to climate change. Welcome to the podcast.
Thank you so much.
And we also have Dr. TJ Young. You are a lecturer in physical geography at the University of St Andrews, and you're researching the dynamics of fast-flowing glaciers and large ice sheets and how they respond to changes from past, present and future climate. But also, closer to home, you have been doing work in collaboration with Scottish Water, investigating ways to improve stormwater management in Dundee, which is where I'm from. Thank you for that.
That's right.
And you have been doing this through novel geospatial and remote sensing frameworks, but also combining historical records from the jute industries, one of the three famous J's of Dundee, so that we can tackle water security for sustainable futures. Welcome to the podcast.
Yep, thank you very much.
And we also, from Dundee, have Ailsa Guild, who is a lecturer in environmental sustainability in the Division of Energy, Environment and Society. And your research is actually based in Iceland, and you have gone there on over 20 research trips.
Yes,
fantastic. And the aim of your work is to understand fully glacial land systems and how these evolve through a period of a warming climate. But also, more recently, you've been involved in researching how science can help inform decisions and policies relating to geotourism. Specifically let's see if I get this right, the Vatnajökull National Park, which is a UNESCO World Heritage Site.
Close enough, yeah.
Close enough. Well, welcome to the podcast, everybody. And I think to get us started, maybe TJ, what on earth is the cryosphere?
So I think the best way to describe the cryosphere is a collective term that encompasses all things snow and ice. So perhaps the most obvious examples or the most obvious aspects of the cryosphere are perhaps the Arctic and Antarctic oceans and continents and the North and South Pole. So for the North Pole, it is surrounded by land, but the North Pole is actually situated on ocean, and it's the opposite for the South Pole, where you've got the Antarctic continent surrounded by oceans. I'm sure my colleagues here will explain other aspects of the cryosphere, such as the Himalayas, the Andes, permafrost, for example, and sea ice and frozen aspects of the sea.
So it really is those cold environments. Mm-hmm. Do we have any of those in Scotland, Ailsa? Anything that you would class as a cryosphere?
Well, Scotland used to be part of the cryosphere because about 33,000 years ago, Scotland was covered by ice in a period called the Late Devensian period. And that lasted, the ice in Scotland lasted till around about 11,500 years ago. And now we're in a period called the Holocene, where warming climates meant that we don't actually have any ice left in Scotland.
Wow.
Yeah.
And you all work in different locations around the world looking at this. Why is the cryosphere important when we are thinking about climate change?
So I think there's three main reasons that the cryosphere is important for our changing climate. And it kind of can be broken down into sea level rise. So as ice on land melts, it flows into the ocean, and this increase of volume of water in the ocean causes it to rise. The second is it can change global climate patterns. And so as you get fresh water going into the oceans, it changes how the oceans move. And this changes how heat is transported. So generally, heat is transported northward to the poles from the equator by the oceans. And if we change these little conveyor belts, it's going to change how our weather patterns migrate. And the last one is for water supply. And so there's billions of people across the world who rely on glaciers in mountains for their year-round water supply. So the Himalayas are sometimes known as the third pole because they have the highest concentration of glaciers outside of the Arctic and Antarctica. And the meltwater from these glaciers provides rivers like the Ganges, Brahmaputra, and the Mekong that gives water supplies to billions of people in India and China and all the way down. And so if these glaciers melt, we want to be sure that we know what's going to happen for water supply for all of these billions of people.
It's also important because it's a very sensitive indicator of climate change, because obviously the cryosphere is very reflective because it's normally white. And so this reflects light back into the atmosphere, which cools the earth. And so changes in the cryosphere regarding its location and its size, that will really change climate on Earth.
And I remember learning about that myself at uni, and I think the analogy is, you know, if you had a mirror and you shone a torch on it, that light would all bounce back.
Yeah.
But if you had, I don't know, if you sit in a black car on a warm day, you just feel that absorption. And so absolutely that change is happening. And I guess my question is, you are all based here in Scotland. You're part of St Andrews University and Dundee University, and you have done a lot of your work even here in the UK. Why are you not, you know, studying somewhere else? Why are you here in Scotland, but also why are you studying these different locations around the world, TJ?
Yeah, so I think if we go back maybe 50 years or so, it would have been a lot easier to answer your question because we didn't have satellites imaging the Earth. So then we had to go to these places and understand the processes that are happening on glaciers and ice sheets in person to be able to get enough information to feed into modeling how these glaciers and ice sheets evolved to contribute to potential future sea level rise. Now that we have the advent of satellite imagery that can take essentially photos of almost anywhere in the Earth at down to sub-meter resolution, people may ask then, why aren't we relying more on these images? And of course we are. We're using these images to look at how changes on the Earth's surface is impacting the cryosphere, so glaciers and ice sheets. But importantly, most of these satellites only look at the surface and not beneath, which is where a lot of these processes are happening because those are the points of contact where glaciers meet the land and thus move because those points of contact act as perhaps areas of friction or areas of lubrication that determine how glaciers move from land to ocean. And so myself, as well as many of my colleagues, are really interested in these processes because it's these processes that determine how accurate we can model the evolution of the glaciers and ice sheets, and thus better predict in both accuracy and precision its contribution to future sea level rise.
I know, I think when I think about glaciers or big ice structures, I have the word calving in my head when you see a big wall of ice and then you hear some cracks and it's quite dramatic and it's normally in Blue Planet or something like that. And whole big chunks fall off and you hear, you know, how big they are. They're the size of a small building or a small country. And I guess that's what I have in my head. When Ailsa, you've been out to Iceland many times. What are you looking for when you go there? What are you measuring?
Yeah, so my research really looks at land systems, like you said in the introduction. And the benefit of looking at a land system as a whole is the ability to reconstruct past environments. And so my work looks at linking structures you can see on glaciers and in modern glacial landscapes to the processes that you see off ice in terms of the landforms and how the debris has moved through the ice and been deposited, and then how these landforms can act as paleoclimatic indicators. So, for example, a lot of the processes that I see in Iceland in a modern glaciated landscape, I can then use to reconstruct what we see in Scotland. So some of the landscapes in Scotland can be linked to the processes that I can see happening in front of my eyes in Iceland.
Fantastic. And Emma, you went on this very exciting trip. I had in my notes that it was 1,000 miles away from Rothera and McMurdo stations. Have I pronounced those correct?
Rotherham McMurdo, yeah, that's
Right.
correct. TJ, I think, is that right?
That's right.
There we go.
Amazing.
Good job.
And you were out there with a huge team, and I said you were imaging the lateral margins of the glacier to understand how it might evolve in response to a changing climate. So what were you looking for when you were out at this West Antarctic site?
Well, TJ, correct me if I'm wrong, but so this was actually the first thing I did as part of my PhD. And so TJ took me along to get some field experience, and we're looking at the edge. So the shear margin is where the really fast flow, it's like the edge of the glacier. You have really fast flowing ice that's flowing from high up on Thwaites Glacier out into the ocean. And then there's really slow moving ice beside it that acts almost like a rock wall. You know, we're most familiar, most of us, with mountain glaciers where you have, you know, the rock and then the ice, and there's that very clear boundary. So a shear margin is just when you have fast ice and slow ice, and it's where that slip happens. And what we were looking for is partially signs in the ice of old shear margins to see if this boundary has moved, because if Thwaites Glacier has got wider in the past under different climates, more ice will have then flowed out into the sea. And so if this could happen, say if our climate warms in Antarctica, and we want to know if that shear margin is likely to move, sea level could rise faster than we might predict if it stayed in the same place.
Yeah, and I think that because we were doing a big imaging survey, so looking within and beneath the big glacier, Thwaites Glacier, and this is something you can't get from satellite imagery. So you have to go there in person, traveling thousands of miles, taking, I think from Dundee, I think at least 7 flights, which is, I understand it's a big carbon footprint, but we need these really hard to get observations. So these are very hard won observations that give us a unique insight and really understand these processes of what's happening within and beneath the ice to be able to better model the future of Thwaites Glacier. And especially, we're focusing quite heavily on Thwaites Glacier because it is one of the most unstable glaciers on the Antarctic ice sheet. And so if the instability of Thwaites propagates into the future, this may potentially even impact the larger West Antarctic ice sheet. And the amount of sea level rise if Thwaites Glacier completely collapsed would be on the order of maybe about 3 meters. And if it impacts the West Antarctic ice sheet, that number could very well rise to much higher numbers. So Thwaites is one of many glaciers worth studying, but because it's happening, all these really exciting but also unfortunate events are happening right in the very present. It's important that we study them right now and put in that effort to travel there to really understand how these effects are happening and how that can inform other events that may happen in the cryosphere and glaciers in the future. And
I'm not familiar with different glaciers, but is this the one that's the Doomsday Glacier that people talk about?
Yes. Yes, I think people have varying opinions on the name, but I think, in my opinion, the aspect of Doomsday could perhaps give you a negative connotation, but at the same time, it gives you that importance. The Thwaites Glacier is at the edge of what if it could become stable or unstable, and so understanding that dynamic instability is fundamental to understanding kind of the present and future of the West Antarctic ice sheet. And the larger Thwaites Glacier program, which is formed of 8 separate projects, investigates the past, present, and future because we need to understand what's happened in the past to be able to know that similar conditions in the future may follow processes that has been recorded by past remnants. And understanding the present could give you that insight into dynamic processes that then feed into models that Emma uses, for example, to then be able to enhance or improve the accuracy and precision for predictions of glacial flow that then impact our estimates for sea level rise.
And I think sometimes it's helpful as well as scientists that something does have a bit of a catchy name, because it means we can talk about it and get it into the attention of people. But I guess one of the things I'm wondering is, we're here in Scotland. Why on earth do these things matter when we're talking about ice sheets and glaciers and the Himalayas and the top and the bottom of the world? Also, why are we concerned about any of this when we are, as you say, living somewhere that used to be part of the cryosphere but no longer has all year round frozen environments?
Yeah, so changes in the cryosphere will be felt in Scotland in many different ways. Changes in the cryosphere will change our climatic conditions in Scotland. And I like to think of it as a feedback loop. And some of what TJ was just saying is about tipping points. And we really need to understand these tipping points to really predict for the future. And these feedback loops that the cryosphere will impact things like sea level rise in Scotland, the temperatures of our seas as well, and our storm days and our seasons, our weather seasons. And so to understand the impacts that we're going to feel in Scotland, we really need to understand what's going on in the cryosphere, because they have such an impact on feedback systems. So, you know, climate influences the processes in which our rivers or our coasts are built and our mountain landscapes are built. And so that all then impacts, you know, human lives and also, you know, animal lives as well, and where they live and where their habitat. So it's all about feedback cycles, and everything is linked. So you really need to understand the processes and understand how they're going to affect each individual feedback loop.
And I think my basic science brain is also going to the water cycle, right? Like,
indeed,
we always have the same amount of water. It's just in different forms. So it might be locked up in an iceberg, locked up in soil. It might be in a loch, in the ocean, in the atmosphere. And as we begin to change the way of that makeup, we might see more water and less water in different spaces. And that's obviously important. I guess, Emma, are there bits of Scotland we should be concerned about when it comes to some of these sea level rise, flooding, or some of these other issues that we're seeing?
I think Scotland as a country is already preparing for the effects of sea level rise and flooding and increased storm events in future. And so I know anyone from Dundee and Angus will be aware of the big storms that we've had in the past few years, where we had large flooding events. And events like this could become more severe in future if you have a higher sea level rise. Coastal erosion as well, with higher sea levels. Scotland as a country, a lot of us, or at least some of the listeners, might have done higher geography, and you learn that the land in Scotland is rising because glaciers used to press down on it, and so the land is springing up, and this is why we have all of our raised beaches around the country. And so for a long time, Scotland was fairly confident that rising sea levels wouldn't affect us. But we've become to realise now in the past few years that the land rising is slowing down, and actually because of all of this extra water being put into the oceans from the ice sheets, the sea levels are now rising faster than Scotland's land is rising. So the Scottish Government is already having climate adaptation plans for things like flooding and flood defences and protecting our coasts from coastal erosion. And but I think the main strategy for Scotland is reducing emissions, because the largest cause, we haven't really talked about this, but other people might, the reason that the ice sheets are of such concern is because they're melting due to climate change. And the best way to slow down the effects of rising sea levels is to cut down on our carbon emissions. And so I think that is what Scotland is already planning for, to adapt. But certainly by 2050, I think there are regions of Scotland that will suffer flooding. I know that we're in Glasgow right now, and so the hydro is all on the banks of the Clyde, and that is all at risk. TJ was talking earlier that I think Glasgow Airport as well is will be one of the earliest hit places with flooding. And so the big question for us as scientists is, how quickly are these flooding events going to happen? How quickly is sea level going to rise? And how much? because if we do cut our emissions, there's every chance that we can slow down this rise and give us more time to adapt to the rising sea levels.
And I think that's important because often when we talk about climate change, we talk about mitigation and adaptation. And a lot of that adaptation is, okay, this area is getting impacted by flooding. How do we adapt? How do we change? But actually we need to think about that mitigation as well and say what's causing this. The classic analogy is you've got an overflowing bath. Before you begin to mop up, you would probably turn off the tap. And so we need to do a bit of that. Yeah. But thinking of those areas you mentioned as well, TJ, you've done some work in Dundee with Scottish Water looking at flooding and water. Dundee is also a kind of coastal / river estuary environment. It's also tiny and it's right next to the river, so it wouldn't take a lot to, I guess, cover the land. Do you want to tell us a bit about the work you've been doing there?
Yeah, so I'm sure my collaborators, some of which also featured on the show, will cover some other aspect of it. But we're looking at the impacts of flooding, both coastal, but also flooding from excessive rainfall. So not from the sea, but from the sky. And we're looking at how different strategies to mitigate excessive flooding can be done in Dundee to better help the city adapt to these climate risks. And so this involves not only long-term strategies to cut down on carbon emissions, which ultimately is the root cause of a lot of these issues, but also needing to think short-term to solve kind of patch certain aspects in the more or less impacted climate. So, for example, Dundee's industry created this very large network of drains that, through the course of urbanization and modernization, have been forgotten, but still exist beneath the surface. And so a strategy that we are looking into with Scottish Water is to see whether or not reconnecting the drains from the jute industry can relieve some of that pressure and move some of that water away from areas that are constantly being flooded. So this is not only a savvy or cost-effective solution, but also reduces the need to plan large infrastructure projects because the infrastructure is still there, just disused at the moment. And so we're talking about kind of both short-term solutions as well as addressing the long-term solutions. So, for example, if we tie it back into looking at kind of coastal flooding measures, for example, in Dundee has a coastal flooding protection scheme where they're building barriers on the seawalls to prevent the sea from overtopping these boundaries. And while that costs on the order of kind of 5 million or so pounds for these projects, if we don't build those, the amount of damages that would cause to both residents and communities and organizations, companies, would be on the order of hundreds of millions. And so it's worth to put in some of these small efforts to address it in the short term while also focusing on relieving greenhouse gas emissions to solve the underlying problem, because measures such as flood protection is only patching the solution. It's not actually solving it.
And when you look at these glaciers and are you modelling for a little bit more ice melting, or do you ever model for if they were never there? I guess that's kind of an extreme example, but how do you set your models so that you work out how much water might be coming to the rest of the world? Usually
we talk about modelling in within about 100 years or so for a short-term understanding, and then we could extend that to 300 years, which is what kind of international standards are usually suggesting now. So we're now looking at medium-term future scenarios, and then we could go beyond that to looking at what happens if all the ice melts. And for example, if all the ice melts, we'd see sea level rise go up to about 70 meters, which is a huge amount. It's obviously not going to happen in our lifetimes, but at the same time, we're seeing sea level rise happen much faster than anyone had expected from studies that were done only about 10 years ago. And so it's important to get these different scales in terms of modeling to be able to understand what might happen at different points in time, and perhaps looking at the severity of what may happen at these points in time to look at these possible scenarios. So a lot of the coastal flooding scenarios, I'm sure it will be covered by other episodes. We'll be talking about a quote unquote 1 in 200 event such as a storm surge, which is, in my opinion, perhaps misnomer, because we're seeing these 1 in 200 events more than 1 in 200. And so I think we also need to kind of look into the underlying terminology and maybe add some caveats into that. And so it's kind of these types of examples that suggest that we need to look at these extremes and incorporate the poles and the cryosphere into that to account for what's happening in real life rather than what's on paper.
It's interesting when you talk about the work you were doing in Dundee and some of this modelling work, because in my mind, you're all very techy, you get to use satellites and fantastic AI, but often you are going back in history to see what was there before, so the jute industry and some of the infrastructure they put in, or trying to reconstruct what was in the past. In my mind, climate change is a future thing. It's happening now and it's getting worse, it's moving faster, and it's a future problem. Ailsa, why are you trying to reconstruct past environments? What usefulness is that to us today?
Yeah, so why it's important to reconstruct is because we need to know about past environments to really inform our models and our predictions in the future. So the reason that we can reconstruct is because there has been natural cycles of climatic changes in the past. So if you take Scotland, for instance, around about 33,000 years ago, Scotland was covered by an ice sheet. And this ice sheet then started to melt around about 15,000 years ago, just over 15,000 years ago. And then we had a period of re-advance where the cold climate then came back, and this is called the Loch Lomond Stadial, or the Loch Lomond re-advance. And this was about 12,900 years ago. And then the Holocene, which we're in now, means that climate change has drastically changed. And between now and about 12,500 years ago, all of the ice in Scotland disappeared. And it's really important to understand the natural cycles of the climate to then understand what impact humans and the emissions are having on these, and how might that then change in the future. So it's really important to understand climate change. You need to look at the past and look at what's happened before anthropogenic impacts that humans are making were really taking effect. And so that's kind of the underlying cause as to why we reconstruct past environments.
A recent study has looked at what has happened at Thwaites in the past and observed that in previous cycles of climate warming, Thwaites Glacier has retreated, but also there's evidence to suggest that Thwaites has recovered from that retreat. And so with this study, it shows that by addressing the issues that we have in global warming and climate change, it's possible to reverse or recover these glacier extents and glacier volumes. But at the same time, the recovery of Thwaites in the past was shown to be about the order of several thousand years. And so we can't rely on the glacier recovering to be able to fix the climate system. We have to kind of address things now. So I guess so basically, we'll need to address all these issues in short, medium, and long term, and thus look to the past to understand how we can understand better the present and predict the future. For that.
Yeah, I think it's really important because the question I get asked most is, are all the glaciers melting? Are they disappearing? And
well, that's because that's what I've heard. You know, I mean, that's
and yes, generally, yes, the glaciers are melting, but there's a natural cycle that goes on there that I have to explain to people. Yes, okay, the glaciers that I'm studying in Iceland are retreating, but actually some of them are advancing as well. So, it is doomsday, but actually there's natural cycles we have to take into consideration. And some of these glaciers are actually quite healthy, but others aren't. And so there is good and bad. So I don't like to be very doom and gloom about it when I'm asked, but in general, yes, but there are natural drivers that will drive these glaciers to advance and then retreat again. And it's really important that we understand those cycles to be able to both reconstruct the past, but also predict the future as well.
And when you talk about the Holocene and these different time periods, those are thousands of years. And I think, scratching to the back of my head from when I learned this, they're kind of named after something that was an influence. And thinking to now, you mentioned anthropogenic impacts. That just means human activity. And I've heard people talking about actually now we're in an Anthropocene.
Yeah.
Would you agree with that, Emma?
I think this is a very contentious
I know it's
topic.
controversial.
And so I think a lot of people, there's very good grounding behind the term. It's to reflect how human activity has impacted the planet, because the amount of carbon I come from a geology background, and so a lot of what we learn about geological timescales and the naming of these, they're called epochs. These timescales, like the Holocene, the Anthropocene, is generally seen in the fossil record. And so as you go, say, from the Jurassic to Triassic or something
this
like
is testing
that.
you get it right.
Back in the day. It's because generally you see a mass extinction of some sort or something changes in the fossil record. And so those rocks are different. They show that the world changed rapidly over a very fixed boundary. And so scientists wanted to say the Anthropocene because if you look at the ground that we're working on, we have heavy agriculture, we have plastic. So when the rocks get made from the ground that we see under our feet, they are going to look very different. But I think last year there was a big General Assembly who tried to work out when would we put this boundary, because technically humans have been around for hundreds of thousands of years. They've been evolving and we've been doing farming for thousands of years. Or is it since fossil fuels in the 1940s, 1890s?
The Industrial Revolution.
The Industrial Revolution, exactly. And so there was a lot of debate over when this Anthropocene would start. And so actually the General Assembly rejected the term. But it wasn't because the humans aren't having an impact. It was purely, I think, just that it's so contentious and we don't have fixed. We just couldn't agree. We couldn't come to a consensus. And so for now, we are still in the Holocene. But as an descriptor of I think Anthropocene is still a very useful term for us to convey to people the importance, the footprint that we are having on the planet currently.
Yeah.
Yeah, it's all about timescales. Yeah. And I guess Anthropocene, it's really hard to put a timescale on that, like you've said, Emma. Yeah, I think it's...
And if we're going to get one of the other problems, this is more going into human geography, is that Anthropocene says that all people are responsible for this. And there was some feeling that it's not equal. It is not. All people around the world have not contributed equally to the current climate scenario. And so I think they thought it was maybe unequal. And so there were other terms thrown around. And so it was quite a complex issue that geographers love to talk about. So it's a good one to bring up.
I'm glad I brought it up.
Yeah.
Yeah, and I think it's important though, because as you say, if we were to be in 1,000 years' time and going on an archaeological dig, and we would come across stuff from today, and you'd realise we have changed the face of the planet in many places, and almost as drastically as some of these other extinction events that have named things. And I think that is just really telling of the impact we're having and how you guys are seeing that on the front line of this cryosphere ice environment. And I think that's been really helpful. Thank you. I guess to share a bit about, one, why should we care about stuff that's not happening in Scotland? We don't have any of these permanent frozen structures, because we are going to be seeing those impacts, particularly with water, coastal, sea level rise, flooding. And also just because globally we're all connected, right? This water moves around. So what's happening there? And it's also helpful to know why you're studying where you are, but also what time you're studying, because I guess I'd never really quite grasped the importance of going back in history and understanding what has happened. TJ, looking at your work now, what are some of the things that you're seeing in the field or when you're back at your research lab that I'm imagining is very high tech and special in St Andrews, but what are you seeing as part of your work?
Okay, first of all, not very high tech, but enough that we can do our work without needing to spend hundreds of thousands of money on kit that I'm only going to be using once. Mm-hmm. But at the same time, if I think about kind of all the research expeditions that I've been on over the course of 10 years, how time flies, 10 years, and most of my work has been on large, fast-flowing glaciers on both the Greenland and Antarctic ice sheets. And while these glaciers are quite large, so you don't really see climate change affecting it on a year-to-year timescales like you see in the Alps or Iceland, for instance, you see that the glacier processes that are occurring on the surface are really dynamic and really respond quite rapidly to changes in climate. So, for example, in the summer, the Greenland ice sheet is more or less above freezing. So most of the Greenland ice sheet is above freezing temperatures in the summer. And so what that happens is it forms these superglacial streams, so rivers that flow on the surface and carve out kind of channels through the ice. And because it's above freezing, that all that melt is happening and has to go somewhere. So the rivers are flowing on the ice, and then at some point it could intersect a crevasse or
and that's just a
hole.
huge big hole, isn't it?
Yeah. So when the rivers intersect a crevasse, it goes into the crevasse and generates what we call a moulin, which then forms a huge hole that connects the surface into the interior or even to the bottom of the ice sheet. And what happens then is that water, if you simplify these processes, could potentially act as a lubricant that enables glaciers to flow faster because you've got that water lubricating the interface between the ice and bed. And so if I actually think about one of the very first times I was on the glacier in 2014, I was collecting water to drink because you don't have to melt water at that point. You can just collect it from the nearby superglacial stream. And I took a bit of a tumble and fell into the water by accident.
Oh my goodness.
And that was first of all a learning point. Don't do this by yourself. You need to be with someone so they can rescue you. And second of all, it did show me that actually there's just so much water, and all of that's happening kind of as a result of climate. And while this isn't a example of climate change or global warming, it shows that glaciers can react quite almost instantaneously to climate change. And so it's really fascinating to observe this up front. And that also provides a really unique perspective and perhaps even almost a necessary perspective of why scientists like us will need to at least see what we're studying in person to be able to get and represent that in our research and perhaps even in our modeling, because it looks so tiny on a screen. But when you go there and travel to your study site and it takes forever, you actually, all that ice in the glacier that's maybe like a few centimeters on your screen, it equates to potentially meters of sea level rise if it melted.
And seeing it, as you say, seeing that water flow past you is so influential. And also seeing that it's not an icy landscape. There is water, and you can see how that process works.
Yeah, I think that people think about the change that happens in glaciers on a, oh, this is so cheesy, but on a glacial time scale, right? So the assumption just by linguistics alone is that glaciers change really slowly, but actually things are happening really fast and almost instantaneously on glaciers, as well as that long-term change that is kind of the underlying assumption.
I'm going to think about that next time I say something's happening at a glacial pace. But actually, it's quite fast. What about yourself, Ailsa? What are you seeing in the field?
Yeah, so I've been going to Iceland since 2016 and I've had quite a lot of trips. I've been very lucky. Some of those trips have been, undergraduate field trips as well as my own research trips. And what we're seeing in Iceland, specifically on the southeast coast, is that these glaciers are really sensitive to climatic changes because of their maritime location and their...
and maritime just means kind of ocean, isn't it? They're surrounded by the ocean.
Yeah. And so, like TJ was saying, it doesn't actually, these changes don't happen on a glacial pace. So since 2016, we have seen major changes in the glacier landscapes and the land systems. And really one thing that sticks with me is that I was trying to explain what the changes we were seeing to some of the undergraduate students before we took them out. And I was saying, just think of it as the landscapes we see here in Glen Clova and other places that we take the students quite locally. The landscapes that have been shaped by glacier ice here in Scotland are being uncovered every time I go to Iceland. Every year I go, I see something different.
Wow.
And that really, when then we took them out to Iceland on their undergraduate field trip and really seeing them kind of put that into perspective, Ailsa said, we were seeing these landscapes and seeing that connection that they had while they were there. That was when I realised, this is definitely a career I want to do forever, because it's so important that these students, make that connection to what they see around them in their local region and what they're taught in the classroom, and then to take them on field trips and see that connection happening and is really important, and that's why I do the job I'm in. So I think Iceland's a great place to look at very large changes on a very short time scale.
It's just amazing to hear about your work. And Emma, you're right at the beginning of this career, so you're doing your PhD. I guess what are some of your reflections hearing from both TJ and Ailsa, but also with your own journey, stepping into this space, what you're seeing as your research progresses?
I think it's very interesting because, you're hearing about people who've gone back many times and seen all of the quick processes. And this is something that really struck me when I went to Antarctica. So this was the first thing I did for my PhD was apply for 4 months of leave. to go
great start.
I study the oceans in Greenland, but it's very important. I think TJ had the opportunity for me to take part in field work to go and get that sense of perspective. So just to go work on Thwaites. And I always pictured Antarctica because we'd learned it's a cold desert. So I thought it's frozen in time, nothing changes. It'll just be really cold and terrible. And then I got off the plane, and it's kind of in McMurdo, which is the big American station, which is on the coast. Sort of. So you have the sea ice and the mountains and the land. And I thought, this is the Antarctica I recognise from the telly.
Yep.
You have Mount Erebus, which is a big volcano, which has a little plume of smoke that comes out of it. You see the big Weddell seals and you see the penguins. And I was like, yeah, Antarctica, I recognise this. And then, a month later, we flew out to our field camp, the first stage where we were going. And I got off the plane, and it's flat white. The plane was 3 to 5 hours to get to the middle of the ice sheet. So it's called Waste Divide. So it's the West Antarctic Ice Sheet Divide. So it's the top of the West Antarctic ice sheet where all of the ice flows out. And I got off the plane, and it was flat in all directions. You could see nothing. And TJ said, "Welcome to the real Antarctica, Emma." And I thought, it's so big. And then this is a big camp of 60 people. This is where we dump all of our science equipment ready to go on to Thwaites Glacier. And then you fly in this tiny little plane. It's called a twin otter. And you get up there and you have these windows. Because in the big plane where we went to this field camp, we didn't have windows. So I remember sitting on December 23rd in my Santa hat, and I was sitting with my friend Andrew, and we're sitting looking out of the window, and you're really high up, and even from that high up, it's flat. You can see nothing. It's just ice for miles and miles. It feels like you can see to the end of Antarctica, and it really showed me how big the continent is. Mm-hmm. It's massive, and you land, and then eventually, I thought, I was like, oh, TJ, the real Antarctica has penguins. And I came back to McMurdo at the end and I was like, yeah, I think I'd never really appreciate the scale of how much ice is there, because you sit on our camp and, you're sitting eating your breakfast or whatever, and you think there is 2 kilometres of ice beneath my feet right now. It was crazy.
I think that was, correct me if I'm wrong, Emma, but prior to that experience, you had little to no experience of camping as well. So we very much threw you in the deep end.
Fire. When I got invited to the field trip, all I saw in the emails was, would you like to go to Antarctica? And I went, yes. Didn't even think about it. I later found, maybe you told me it was camping and I just hadn't, registered it. But no, I'd never been camping. I was lightly afraid of midges, mud and rain, which is all you get in Scotland.
Thankfully, you don't get that in
Antarctica. It's actually kind of very nice camping. So I camped for the first time successfully on the McMurdo ice shelf. But before I went, I'm a responsible person. I did try. I went into my garden with my childhood tent twice. Once was in April, and I had my brother's 20-year-old sleeping bag, and I lasted till 3 a.m. And then the second time was about a month before the trip, because at that point I was like, if I haven't made it through, I'm done for. And so I went back out in the same tent, sat down, 2 a.m. and I was inside. And so I was on that plane to Antarctica going, I think all of my family at home were sitting there like this, they're like, what has she done? But I loved it, and I came back from Antarctica. I went to go outdoors and I bought myself a nice sleeping bag and tent, and now camping in Scotland is lovely and I can do it. So thank you for some additional skills, TJ.
I think maybe it might be a good opportunity to mention that when you think of a glaciologist or a polar explorer, people often think about kind of this rugged looking, perhaps kind of intimidating looking man. But I mean, for better or for worse, I don't think we're that big or imposing here. And so I think hopefully, if anything, this episode can also kind of reimagine what being a polar explorer or being a glaciologist is. And you could look like anyone. I would say that we are normal people. We look relatively normal. And so I think hopefully this is a good example that anyone can be a glaciologist as long as you have the interest and the passion. And not even just glaciology, but maybe any aspects of geoscience that we'll be talking on the show. It could be anyone off the street. You could look like anyone off the street, I think.
Yeah. And we're a particularly fieldwork heavy, cohort with the three of us, but not all of glaciology is about fieldwork. So it is something that is important to say, that it should be accessible to anyone who cares about, if you really love glaciers and you go, oh, but I'm not outdoorsy, I don't like camping, or there's other things you can do. I signed up to a modelling PhD because I thought I couldn't go camping. Turns out I really wanted to do fieldwork. I just didn't think I could. And I don't think that is a good barrier for people to have. And so,
can I just add to what TJ said? Because I think it's really important. That's a really important message. If you're passionate about something, you should really pursue it. Because, I'm forever thankful for the Dundee University Access Summer School. So I didn't get the grades to go to university in 2010. That's a long time ago. And so I didn't think I would ever be sitting here as someone who's finished a PhD and gets to go to these wonderful places. And I always feel extremely lucky. And I've worked really hard to get where I am. But I'm a real advocate for, if you've got a passion for something and maybe you're not a straight A student, then please don't worry. And, you need to follow your passion, because that's what I done. I worked hard. I took every opportunity that came to me. I'm here and I feel extremely lucky, and I want to encourage anyone who has, a passion for any geoscience or anything that they want to do, to really follow that.
Oh, I think that's a brilliant reflection as well, and something that we are hoping will be showcased, throughout this podcast series, is the breadth of people as individuals who are doing research in this space, but also that there are different institutions, different backgrounds, different nationalities, genders, and people who've had a different journey to get to where they are. So thank you for sharing that. I think that was a special thing to add. But I guess I want to end on a slightly more silly note, but I guess that's glaciers make some pretty cool places, okay? So when you think of Scotland, people think about Glencoe, the kind of big glaciated landscape. You might think of Edinburgh Castle, which I guess is on an extinct volcano, but has been kind of carved out. And there's loads of other examples of where we have amazing, cool, glaciated landscapes. And people travel around the world to see that. Ailsa, I know that your work has been focusing on the impact of that, and it's called geotourism. Give us the correct pronunciation for where you're looking at this, because I butchered it at the beginning.
So my research is based in the Vatnajökull National Park.
I was close.
You were very close. And Vatnajökull National Park has seen a tourism boom since around about 2010, when the volcano that erupted and caused quite a lot of ash to go into our atmosphere and delayed and cancelled lots of flights. Iceland came on the map because then we were seeing lots of really cool pictures of volcanoes and really nice glaciers, and everyone thought, wow, I'd really like to go there. So since 2010, Iceland's economy has really been relied really heavily on tourism, and still does to this day. And so Iceland, prior to 2010, Iceland weren't getting the number of tourists that they are now. And they don't really have the facilities to deal with the number of tourists that are visiting, especially the southeast coast of Iceland, where all of the very pretty and picturesque glaciers are. And so, Iceland's roads aren't really constructed for a lot of travel. And also, simple things like there's no car parks. And so what we're seeing now is that as tourism increases, people are pulling off the roads, and it's a volcanic island, so the roads are very soft. So we're seeing lots of car accidents, and we're also seeing a lot of the natural heritage of Iceland being lost for things like car parks or accommodation. And so part of my work is to look at how can we apply environmental science to really help the policies and the national parks educate the tourists, but also understand why these landscapes in which they're now using for geotourism are actually really important for scientific interest. And so I'm trying to apply environmental science, for a sustainable future for geotourism in Iceland. But you can see some of the problems that are happening in Iceland in Scotland. So, for example, the Isle of Skye. The tourist numbers that were visiting the Isle of Skye have boomed in recent years. And there's been problems with people blocking really important access routes because there's no car parks. And so we really need to understand how to allow everybody to experience the natural environment which the cryosphere has shaped or is shaping still, so that everybody can experience these, because it's great that people are interested in to going to these places, but we just need to make sure that everybody can experience these places in a very sustainable way.
Yeah. And, I even introduced it going, this feels like a silly question because we're talking about sightseeing, but actually what you say is so important. And so are you finding it's an open door to help with this? Because as you say, I went to Skye on holiday, and me and my mum went round all the spots you could imagine. And the one thing I noticed, I thought, everybody here, we're all going to the same things. They should get an open top bus or something. But actually it did make me think about the impact we were having as just the two of us. surrounded by all these extra people.
Yeah, I think in Iceland, the Vatnajökull National Park are really trying hard to educate tourists, but also I think it's really important to get the tourists involved in the science. So through citizen science schemes, we're trying to get the tourists to take photos, for example, from the same position so that we can map retreat of certain glaciers. And by involving the tourists in this, it's helping to educate them. So it is an open door. There is different policies. The Vatnajökull National Park in Iceland is now a UNESCO World Heritage Site, and with that comes protection as well. And so I do think, yes, we're going in the right direction, but there is still quite a lot to be done. And I think, in my opinion, the main factor is educating people as to why these landscapes are important to both reconstruct the past but predict the future. And hopefully this podcast helps with that as well.
No, I think that's great.
One of my favourite places in Scotland. I wrote this on my application form to go to university to study geography.
So it's a top tip then for any people thinking of
if you want to go somewhere in Scotland to see awesome glacial landforms, go to Corryfee in Glenclova, because it's a lovely walk. It's not too steep, but they have these signs all over the walk that they point out features like something called erratic boulders, which are big rocks that have been dropped by the glaciers. And you can see moraines, which is a bunch of gravel that's been dropped by the glacier. And I promise it's exciting. But you walk along and you go through the forest, and these signs help you understand what you're seeing and tie it to the glacial landscape around you. So I went when I was maybe, 15, because I was a cool kid. And I went and I looked at all of these signs and I read them, and I didn't study geography at that point. I didn't really know that there'd been glaciers in Scotland, but I went through and I saw it. And then you exit the forest and there's this massive corrie. It's like a big bowl. It's very pretty, even if you're not a glaciology person. But I remember standing there and going, oh, there was an ice sheet above this. That's really cool. And so so we drop for Glenclova. Go responsibly, Carshare, you know. But it's a really nice place to see that Scotland has these as well. And we initiatives like this to bring education to tourists, bring that value of the landscape, and can really tie people to their environment and teach them something about it.
Yeah, definitely. Yeah. Yeah, I second Glenclova. It's one of my favourite places in the world. So, yeah.
And you've been to Iceland so many times. That's a real plug.
Iceland is number one, but Glenclova is number two. Yeah, definitely.
I know. And I think that's it, isn't it? It's getting people involved. And even, you're scrolling through social media, and sometimes you do stumble upon someone who has been to an ice sheet 20 years ago, and then they've revisited it and they've shared, the same photo, and it's drastically different, and it is quite shocking to see that. But equally, it's just as inspiring to then come back home and actually see how some of our most iconic landscapes have been shaped by this ice. And for me as well, I think every time I go through Glencoe or Glenclova, I'm also just shocked by the sheer power of these structures that, if you tried to chip away at any of these valleys, you'd get nowhere. But these glaciers just smoothly, I'm sure it wasn't very smooth, I'm sure it was very chaotic underneath, but actually just kind of glided through and created it.
Yeah, I think that's a good point. If you think about the fact that most, if not all, of Scotland was under hundreds of meters of ice at one point in time, and to think how big or how high hundreds of meters is, and think that it's happened beneath our feet at one point in time is quite an impressive kind of concept to grasp. And that hundreds of meters of ice has changed the landscape and shaped it to what it looks like now, and how that has made the landscape so unique and pretty, and a spot that people from all over the world would want to come to Scotland to see. And it's made Scotland such a special place, isn't it?
Absolutely. Yeah. And I feel that's such a lovely note to end on, because it does just remind us about what you are studying and how we can see that here, even if the ice is not here anymore. So Dr. TJ Young, Dr. Ailsa Guild and Emma Cameron, thank you for being part of the Sages Network, being on the podcast, and we look forward to the next episode. Thank you very much.
Thank
you,
you,
Laura.
Thank you so much.